Nomenclature. Nomenclature is a system for naming compounds. And just like people in different countries have different systems for naming their children, we have different systems for naming different kinds of compounds. My kids have to do a family tree project for school, their junior year. And my ancestors came from Sweden. And in Sweden, back in the day, the children did not take their father's last name. They took their father's first name, and if they were a boy, they put son on the end of it, and if they were a girl, they put daughter, D-O-T-T-E-R. And so you ended up with people like, Helga, Peter's daughter. And if Peter Olofsson had a son, John, his name would be John Peterson. And John's son, Niels, might be Niels Johnson. And so it's a different system of naming, right? It's kind of interesting in doing the family tree, but it would be really confusing in real life, which I think is why they got away from that. They don't do that anymore. But that's why many Scandinavian names end with son. So different countries, different systems of naming children, different types of compounds, different systems for naming them as well. So we need to identify what country the person is from, what type of compound it is, so that we know what set of rules to use. In addition to the systematic names, there are many compounds that also have a common name. We're going to worry about two of those only. So the first thing we have to do, we're going to learn how to name ionic compounds. And the first step in that is identifying it as an ionic compound. And the key here is a metal. If you have a metal and one or more nonmetals, you've got an ionic compound. So you look at the formula, and if there's a metal in it, it's almost certainly an ionic compound. Your book talks about two different categories of ionic compound. There are those containing metals that form only one kind of ion, and those are the ones we've learned about so far. Group 1A metals form +1 ions, always. Group 2A, +2. Group 3A, +3. The other metals, besides zinc and silver, form more than one ion. Iron can be +2 or +3, and so we have to add a little bit to the name for those guys. So your book distinguishes between type 1 and type 2. I don't make a big deal out of this division. But the type 1 has a metal that always has the same charge. It only has one kind of charge. And so the ones to remember here are groups 1, 2, and 3, zinc and silver. And we'll be kind of chanting that. Group 1A, 2A, 3A, zinc, and silver. If it's not one of those, it has more than one charge, and we're going to learn that we indicate that with a Roman numeral to indicate the charge. Most of the type 2 metals are transition metals, but not all of them. And so I don't think that's really a useful generalization even. These are type 1 metals. These guys are in group 1, group 2. This is group 3. And then zinc and silver. Let me see if I have a periodic table here. No, that would be too useful. Okay, I'm going to have to draw a periodic table. I'm going to show you how I remember zinc and silver. Okay, so this is group 3A, and here is our friend aluminum. And here's zinc, and there's silver. Aluminum has a +3 charge because it's in group 3. And then these look like they're going downstairs to me. Here's the stairs. Does that look like stairs? +3, +2, +1. aluminum, zinc, and silver. Plus 3, plus 2, plus 1. So this is plus 3 plus, and 2 plus, and just plus. And you just have to remember those guys. These are metals that commonly form more than one type of ion. So we see chromium forms plus 2 and plus 3. And so to name these ions, instead of it just being the name of the element, we have to specify which ion it is. And we do that with the Roman numeral in parentheses after the element's name. So Cr3 plus is chromium with the Roman numeral 3. And in case you've forgotten, Roman numerals are a little weird. I guess that's visible enough. Roman numeral 1 is an I, capital I. Roman numeral 2 is 2 I's. 3 is 3 I's. And you can see how this would get a little tedious if we just kept going on with that. 5 is V. I don't know why. It is. 4 is 1 less than 5. So it's I, V. It's 1 before 5. 6 is 1 after 5. And you can't see those at all because they're off the screen. Stupid screen. I wish I could move that, but I can't. Sorry. Maybe I could do this, though. I'll write it over here. There, now we can see it. So down here we've got lead 4, tin 4. We don't often run into 5s and 6s, but they're out there. This is another system of naming that you'll still come across, but I'm not going to make you learn it. Okay, so ferrous and ferric. The ick and the us tell us which one is the higher charge and the lower charge, but it doesn't tell us what the charge is. So we're going to stick with the Roman numerals. When we name the compound, binary ionic compounds have 2 different elements. We just have the name of the cation, which is the metal, and the name of the anion. The anion is going to be a nonmetal. We take its element name and change the ending to "ide." For type 1, we don't need to specify the Roman numeral because they all have just one charge, which we can figure out by looking at the periodic table. So if we look at NaCl, when we go to name something like this, first look at the first element. Na is sodium, and ask yourself, is sodium a metal? And don't just rely on your thoughts about whether sodium is a metal or not, because you've probably never encountered the element personally. Look at the periodic table. If it's to the left of the line, that stair-step line, it's a metal. Sodium is a metal. Therefore, this is an ionic compound. I'm going to name the cation, and then I'm going to name the anion. So sodium is in group 1. It doesn't need a Roman numeral, so its name is just sodium. Cl is chlorine. We take chlorine and change the ene to ide, and we get chloride, and we have sodium chloride. Most of the compounds we'll name are going to have 2 names, a first name and a last name, just like most people have 2 names. But these are not proper names, so we're not going to capitalize them. So these are some common anions, the monatomic anions. Fluorine is fluoride, chloride, bromide, iodide, oxide, sulfide, and nitride. And the charges are just from the periodic table. So let's name this compound, KBr. First, look at the first element, K. Is that a metal? Yes, it is. What group is it in? It's in group 1. Group 1, 2, 3, zinc or silver, no Roman numeral, just write the element name. What's the element with the symbol K? Potassium. I just don't really mean to stay on this orange color all day. Potassium. And the other element is bromine. So we're going to change the ending of its name to bromide. I think I mentioned to you that I think of the metals as being masculine and the nonmetals as being feminine. And traditionally, when a man and a woman get married, who changes their name? The woman. So here we have the nonmetal changing the ending of her name. The metal doesn't change his name, but the nonmetal does. Let's look at this one. Zn3N2. We have two different elements here. Is Zn a metal? Is it to the left of the stair-step line? Yes, it is. So that is zinc. Is it in group 1, 2, 3, zinc or silver? That's a trick question. Yeah, it's zinc. Doesn't need a Roman numeral. Zinc always has a +2 charge. Why? Because we remember that it does. There's no good reason for that, but that's zinc. We don't need to do anything with this number 3. We're just looking at the element symbols. N is for nitrogen. Nitrogen changes the ending of its name when it hooks up with zinc. Oops. Nitride. This is zinc nitride. We don't need to specify what these numbers are because if we have the name and we're writing the formula, we do it based on the charges. We know that zinc has a 2+ charge and nitrogen has a 3- charge from looking at their positions in the periodic table. And then we do that crisscross thing and we end up with Zn3N2. So the charges tell us what the ratio is, not directly. It doesn't scream it or have it in flashing neon lights, but it's in there. And so we don't use prefixes or anything in our ionic compounds. Any questions? I just did that. Now, type 2 binary ionic compounds. The only difference here is that the metals are not in group 1, 2, 3, zinc or silver. And so we need to indicate their charge with a Roman numeral. So if we have these two ions, Cu plus and Cu2 plus, we need to be able to name them. Cu plus has a +1 charge, and so that's copper with the Roman numeral 1 in parentheses. We do not put a space between the end of the element name and the parentheses. This is just like an extension of its name. And copper 2, because this has a +2 charge. So for these compounds, they take the form name of the cation, the metal with its charge in parentheses, and then the base name of the anion with the ending changed to "ide." The thing is, though, we have to figure out what the charge on the cation is, and we do that by looking at the charge on the anion. So if we look at FeCl3 and are trying to name that, we ask ourselves, is iron a metal? Yes. So we're going to name this as an ionic compound, and we're going to write iron. Is it in group 1, 2, 3, zinc or silver? No. Therefore, it needs a Roman numeral. So I'm just going to put the parentheses there and leave some space for the Roman numeral and continue on with the rest of the name. Chlorine changes the ending of her name to chloride. So this is iron something chloride. Iron needs a Roman numeral to tell us the charge. We don't get it off the periodic table. It's not the number after it in the formula. We have to look at these ions. So if we look at the ions, we've got Fe, and we've got Cl, and what's the charge on a chloride ion? -1. So we look at the periodic table, and argon is on the far right. Argon is a noble gas, doesn't make an ion. So argon's 0, and then we move backwards, -1, so chlorine has a -1 charge. The formula tells us there's 1 iron ion and 3 chloride ions. So I've got the 1 iron, I've got 3 chlorides. If I have 3 chlorides, what's the total negative charge? -3. So, well, so the total positive charge must be +3, right? Because +3 -3, they have to add up to 0. I've got the number of these, 3 of them, from this formula. That's what I'm starting with. I've got the charges from the position on the periodic table. 3 times -1 gives me -3. That means that I must have +3. This +3 is divided over just 1 ion, so it must be +3. Therefore, that is iron 3 chloride. Any questions? Yes?
How did you get the 3 chlorides?
From the formula right here, FeCl3. That tells me there's 1 Fe and 3 Cls. Any other questions? I know it's Ide because this is a non-metal by itself.
So if it's a non-metal by itself, then it's an ion?
Yeah, if it's just a single element, what we'll see is there's some polyatomic ions too. They often have oxygen in them. But if this was ClO3, that would be different. Yeah. Any other questions? No, I kind of already did that. So let's name a couple of compounds. PbO. It's a lead oxide. Lead is a metal, and oxygen is not. This is an ionic compound. Pb is the symbol for lead, so we write lead. Is lead in groups 1A, 2A, 3A, zinc, or silver? No, it's in group 4A. Does that count? No. If it isn't in group 1, 2, 3, zinc, or silver, then it needs a Roman numeral. And so I'm going to leave space for the Roman numeral. The oxygen becomes oxide. And so it's lead oxide, but there are 2 possibilities for lead oxide. And we need to specify it in the name. So we have to look at the charges. So Pb, we don't know what its charge is. That's what we're trying to figure out. O, we have 1 of each. We get that from the formula. What's the charge on the oxide ion? 2-. There's 1 of them. So we've got a total of -2 charge. We must have a total of +2 charge. There's only 1 lead. It must be 2+. Right? So this is lead 2 oxide. The Roman numeral tells us the charge. It does not tell how many of them there are. It tells us the charge. How about Cu2S? Cu is copper. Is copper a metal? Yeah. You find it on the periodic table. It's to the left of the stair-step line. It's a metal. Is it in group 1A, 2A, 3A, zinc, or silver? No. So therefore it needs a Roman numeral. So this is an ionic compound because the first element was a metal. The name of that metal is copper. It needs a Roman numeral because it's not in groups 1, 2, 3, and it's not zinc or silver. S is sulfur, so that's sulfide. So this is copper, some Roman numeral, sulfide. Over here, we've got 2 copper ions and 1 sulfur ion. That's what the formula tells us. Cu2 means there's 2 of those, and S means there's 1 of those. What's the charge on sulfide? 2 minus. So there's a total of -2 charge from the sulfide ion. There must be +2 from all of the cations combined. So we have a +2 charge that's going to be divided equally between these 2 copper ions, so they must each be +1. So this is copper 1 sulfide. There's definitely a learning curve on this, and the way you learn is by doing and trying. It's like learning to play a new board game. They can read you all of the rules, and your eyes start to glaze over, right? And you say, stop, just let's start playing. And you play the game, and you do something, and the people that know how to play the game say, no, you can't do that. You have to do this. And you're like, oh, okay, I hope I remember that next time. But you play, and you make mistakes, and you get corrected, and then you learn, right? I'm not saying that this is ever going to be necessarily fun, but if you practice and learn from your mistakes, it's not just about getting the right answer on mastering chemistry. It's about understanding why is that the right answer. It's going to take a little bit, but then the light will go on. And it's so fun when you explain it to somebody and the light goes on in their eyes and you can tell that they get it. That can keep me going as a teacher for like 3 weeks. One person, their eyes lighting up. It's awesome. It's just this rush. So I'm hoping that happens this week. But you have to persist at it, okay? As one of my kids said, this is not rocket surgery, right? But it's weird. It's different. And so it's going to take a little work to figure it out. Okay? That was your pep talk. I hope it helped. So those were binary ionic compounds. Binary means 2. All of those compounds just had 2 elements. But some ionic compounds have more than 2 elements. And these contain what are called polyatomic ions. Poly meaning many, atoms. So these are ions that have more than one kind of atom in them. And these we need to memorize. And I gave you a short list of these for your memorization quiz. The most common ones to just kind of get you started on it. So there's going to be some more. So these are some of the common polyatomic ions. This is a table in your book. And as you're learning how to do this, try to remember their formulas from memory, but then go ahead and check yourself on the table. Making flashcards is a great idea for learning these things. There's even an app for that. There seriously is on your phone. Yeah. And somehow it's more fun if it's on the phone, right? Oh, I'm not goofing off. I'm learning my polyatomic ions. Oxyanions are one group of polyatomic ions, and guess what? They contain oxygen. So all the oxyanions have oxygen in them. And there are series of these that have systematic names. And so if we look down here, there's NO3 minus and NO2 minus. And the only difference here is the number of oxygens. The number of nitrogens is the same. The number of the charge is the same. And so there's a pattern in the oxyanions. And so this one is named nitrate because I said so. There's no other good reason for that. Why did they pick NO3 minus? They had reasons, but I don't even know what they are. It doesn't matter. That's nitrate, just because. This is nitrite. This is the light version. There's one letter difference here. This is the 8. This is the ite. The ite has fewer oxygens, 1 fewer. Just like Bud Light has 1/3 fewer calories than regular Bud, right? So nitrite has 1 less oxygen. Here's sulfate. You memorize the sulfate, SO4 2 minus. Then you see sulfite, and you say, oh, that's the light version. SO4 2 minus, except it's O3 instead of O4. So there's a pattern in that. Some of the nonmetals form a series of 4 ions. So here in the middle we have chlorate. Chlorite is the light version, 1 less. And then this one, ClO minus, has even 1 less than the light version. So what do we call that? Well, we're going to use a prefix. Hypo is a prefix meaning below or less than. A hypodermic needle goes below your dermis, right? It goes under your skin. One of my kids is just like completely freaked out by needles. Doesn't care about the pain. It's just the idea of something being under his skin. He will never get a tattoo. I would bet lots of money on that. He would just be completely freaked out. But hypo means below. Hypodermic, below the skin. Hypo meaning less. So chlorite, hypochlorite is 1 less than the light. And ClO4 is 1 more than this regular one. So these 8s are the ones that you memorize. You memorize the 8s, and then you learn the pattern, and you can take care of the rest of them. Per reminds me of the word hyper. It means more than. Hyperactive means more active than a regular person, right? So per has more oxygen. The formulas here for hypochlorite, hypobromite, and hypoiodite all follow the same pattern of numbers of oxygens and numbers of halogens. Chlorine, bromine, and iodine are sisters on the periodic table. They're all in the halogen family, and they have many characteristics in common. I have 5 sons, and if you look at them, you recognize, oh, yep, that's a Caligoa boy. And it's just stamped all over them. You can just tell. They all like to play football. They're all learning how to play guitar. They just have these things in common. Are they exactly the same as each other? No, they're not. Chlorine, bromine, and iodine form polyatomic ions with oxygen. They have the same pattern. So really, you memorize chlorate is ClO3 minus. You learn the pattern, and you know all 12 of these. Because if chlorate is ClO3 minus, then bromate is BrO3 minus, and iodate is IO3 minus. You see that? There's a pattern in there. On mastering chemistry gets hung up on some odd little things sometimes. And if I remember correctly, it's a little hung up on the word ion. So if it asks you to name this, it's going to want perchlorate ion. And if you just say perchlorate, it'll probably tell you it's wrong. Technically, that is the correct name. Perchlorate is not the name of a thing. That's part of a name. You could have sodium perchlorate or a perchlorate ion, but you can't have just perchlorate. So it's not that mastering chemistry is wrong about that. It's just being really picky about that. I won't be that picky on the worksheet, but I just want to warn you about mastering chemistry. Many of these polyatomic ions show up in things that we run into in our everyday lives. You've probably used bleach, or maybe your mom used bleach when you got your clothes really, really dirty. Household bleach contains sodium hypochlorite, ClO minus. That destroys odor-causing bacteria and also color-causing molecules. It can also take out colors that you wanted in your clothes, right? Sodium bicarbonate. Okay, bicarbonate is another name for hydrogen carbonate. And I probably should have done this on that little table over there. Carbonate is CO3 2 minus. And if we add an H plus to that, we'll put all the letters together, HCO3, and the charges together, a +1 and a -2 gives us a -1 charge. This one is carbonate. This one can't also be carbonate. So one of its names is bicarbonate. We see that a lot. It's not my favorite. I think it's better to call it hydrogen carbonate. So this is hydrogen carbonate ion, but you're also going to see bicarbonate, so you kind of have to keep in the back of your mind those are the same. That's baking soda. If you've got acid reflux or heartburn and you're popping Tums or Alka-Mints or something, those have calcium carbonate in them. Sodium nitrite is a preservative in packaged meats. It especially kills or inhibits the growth of bacteria that cause botulism. Botulism is really bad news. Now, it turns out nitrites aren't great for you either, and so there's a big movement of people who don't eat processed meats or meats containing nitrites. That's great, but then watch out for botulism. Your meat's not going to last as long, so there's a trade-off on that. But these ions are all over the place. And if you look at the ingredients on the shampoo and your Go-Gurt or something, you can probably find some of these on the label. So we name these compounds that have polyatomic ions in the same way that we named the binary ones. It's really important to remember that in this class, all ionic compounds are going to have 2 ions. 2 ions. 1 positive and 1 negative. And sometimes students get creative and they'll tell me this is manganese nitrogen dioxide or something like that. No, 2 ions. Most of the time, almost all the time, the first ion is a metal. So that one's by himself, and then everything else is the other one. 2 ions. So the first one, Mn, is manganese. Not magnesium, and not magnesium, manganese. Manganese. Is manganese in group 1, 2, 3 zinc or silver? No. So it needs a Roman numeral. So I'm going to put the parentheses there so I don't forget. And now we're going to look at what's left. The parentheses here with the 2 on the outside are saying we have 2 of this polyatomic ion. The parentheses are like shrink wrap. Did I talk to you about bundle packs at Costco? Yeah, so this is like a bundle pack. It's got a nitrogen and 2 oxygens, and it comes as a unit. And we've got the shrink wrap parentheses around it and 2 of those on the outside. So we've got NO2 and we've got NO2. We have 2 of those. What is the charge on NO2? It's -1. How do you know that? Because you memorized that. We should memorize nitrate. Nitrate is NO3 minus. It's not a very good, poor penmanship. If you're writing with a stylus, then it isn't penmanship, is it? Is it stylusmanship? I don't know. Random thoughts. This is nitrate. What's this? Nitrite. It's the light version. So this is manganese, some Roman numeral, nitrite. Spelling matters. Yes?
Is nitride just a different way of spelling?
That's a good question. What about nitride? Because we've got 3 things here. Nitrite and nitride are different in the D and the T. Nitrite and nitrate are the I and the A. Nitride is just nitrogen. That's N3 minus. Nitrite is NO2 minus. Nitrate is NO3 minus. And you might say, wow, that's being awfully picky. Well, it's shorthand. And a whole bunch of people got together and agreed that this was the most straightforward way to do it. So if you can invent a better system of nomenclature, you go right ahead, okay? And when you've got it all worked out, we'll write a letter to IUPAC and say, hey, my student figured out a better way. I don't think it's going to happen. It's a lot of different compounds to figure out a good, concise way of naming it. So this is what we've come up with, and this is just what we have to go with. But it's really important. That's a very good question. What's the difference? There is a difference, and it's significant. These are different compounds. They're going to have different chemical and physical characteristics. Sometimes one of them may be beneficial and one may be toxic. So important to be careful with your spelling here. Now, we need the Roman numeral on the manganese. This is saying that we have 2 NO2 minuses, so the total negative charge is -2. How many manganese ions are there in this formula? Just 1. So its charge must be +2. So if the whole figuring the charge thing out is a mystery to you, please talk to me on Thursday when we do the worksheet, okay? Because I've explained this to, at the very least, hundreds of confused students, okay? And I can do it with bowling balls, and I can do it with cookies, and I've got all kinds of things that I can use. So I'll be happy to try one method after another until we see the gleam in your eye. But that's manganese 2 nitrite. Okay, this guy down here looks like cocoa 3. Two ions. So the metal is the first ion. We have to be careful with lowercase and uppercase letters. This is a capital C and a lowercase o. That is one element. Over here we have a capital C and a capital O. 2 elements, copper and oxygen. And together they make the other ion. So CO is the symbol for which element? Cobalt. Is cobalt a metal? Is it in group 1, 2, 3, zinc or silver? Nope. It needs a Roman numeral. Put parentheses, figure it out later. This guy, CO3. There's more than one element there, right? That is a polyatomic ion. It has a special name. You go look at the table until you've got it memorized. What is it? It's carbonate. And the charge on carbonate is 2-. We need to know those charges because we're going to use that to figure out the charge on the cation. So we've got 1 cobalt and 1 carbonate ion. So this is going to be cobalt something carbonate. I kind of ran out of room there. Let's keep those guys separate. One of these is -2, and there's one of those, it must be +2.
How do you know it's -2? Because of the formula?
Because of the formula, you memorize it. Or you look it up in the table, and there it is, CO3 2-. There is a reason, of course, why it does that. It has to do with electrons and the octet rule and stabilities and energies and stuff. But knowing all that stuff doesn't really help you predict what the charge is. And chemists who understand all that just remember that it's CO3 2-. Just like you remember what your phone number is. And I bet most of you have your student ID number memorized too. Just because you have to write it down so many times, right? Any questions?